Could a fleet of stainless steel rockets solve Uganda's long-running struggle as a landlocked nation? Today, we are running a grounded thought experiment. We will calculate whether SpaceX Starship-class vehicles could ever outperform traditional maritime shipping by launching bulk cargo directly into the heart of East Africa. It sounds like science fiction, and in many ways it is, but the economic and geographic math is genuinely worth examining. Uganda sits roughly 900 to 1,600 kilometers from the nearest major seaports, and most imported goods currently travel overland through neighboring coastal states. That dependency shapes trade costs, national security, and daily prices in Kampala markets. So let us treat the map as our blackboard and follow the actual geography of this idea, from a floating platform in international waters all the way inland to the Ugandan capital. Let us start with the core problem. Uganda is fully landlocked. Its imports and exports move mainly through the ports of Mombasa in Kenya and Dar es Salaam in Tanzania, then travel by road and rail across hundreds of kilometers of another country's territory. This creates long transit times, border delays, transit fees, and vulnerability whenever a neighbor faces political instability or infrastructure failure. On this satellite view, you can see the sheer distance between the Indian Ocean coastline and the interior plateau where Kampala sits, close to the shores of Lake Victoria. The conventional answer to this dependency has always been better roads, better railways, and regional treaties. Our question is more radical. What if you skipped the corridor entirely and delivered cargo from above, using a sea-based launch platform and a suborbital or orbital hop that lands near the destination? Here is the anchor of the concept. Instead of relying on any coastal state's territory, Uganda could theoretically operate a floating launch and landing platform in international waters. Our representative point sits at roughly 3 degrees south and 45.5 degrees east, well out in the Indian Ocean and beyond any single nation's territorial sea or exclusive economic zone. This is a stand-in point, not a real installation, but it lets us reason about the idea. A sea platform sidesteps part of the political problem of transit rights because no neighbor controls the high seas water. SpaceX has already demonstrated ocean-based operations with drone ships and has proposed offshore spaceports. Cargo would be loaded onto a Starship-class vehicle on this platform, launched on a high, fast trajectory, and then brought down near Kampala. On this map, notice how far this platform sits from shore, which is exactly the point. Now let us trace the actual corridor. From the deep-sea platform at 3 degrees south, 45.5 east, the trajectory would arc west-northwest. Our first waypoint sits near the Kenyan coast at roughly 1.88 south, 41.19 east, close to the Lamu and Somali border region. From there, the path crosses inland to a second waypoint around 0.77 south, 36.89 east, in the Kenyan highlands near the Great Rift Valley. Finally, it descends into Kampala at 0.35 north, 32.58 east. This flyover shows the raised terrain along that corridor. Even though a rocket flies far above the surface, the ground track still matters enormously because launch and landing zones, abort trajectories, and any debris footprint all fall on real land with real people and real ecosystems beneath them. The landing side is where terrain becomes critical. A rocket does not care much about slope while it is in flight, but the landing pad absolutely does. Kampala sits on the East African plateau at roughly 1,100 to 1,200 meters above sea level, a dramatic contrast to the coastal launch point at sea level. This hillshade view reveals the rolling hills that define the region around Lake Victoria. Kampala is famously built across many hills, which is charming for a city, but challenging for a landing facility that needs a large, flat, geologically stable pad with clear approach and departure clearances. A Starship landing requires a broad flame-hardened surface, deluge water systems, and a substantial exclusion zone. Finding tens of hectares of flat, stable, low-population land near the capital without displacing communities or wetlands would be one of the hardest constraints in this entire concept. Let us make that elevation contrast concrete. This profile runs from the sea platform at 0 meters, across the coastal lowlands, up through the Kenyan highlands, and onto the Ugandan plateau above 1,100 meters. That climb of more than a kilometer in surface elevation is irrelevant to orbital mechanics, but very relevant to logistics on the ground. A landing site on the plateau means thinner air, which slightly changes rocket performance, and it means any supporting road and rail links must negotiate the same steep escarpments that already make the traditional corridor slow. Notice the sharp rise near the Rift Valley. Any ground infrastructure supporting a spaceport, fuel supply, water for deluge systems, power, and worker access has to climb this same terrain. So even a from-above solution cannot fully escape the elevation problem that has always shaped this region's trade. Now, the financial reality, because this is where the dream meets the spreadsheet. A modern container ship carries over 20,000 20-foot equivalent containers, each holding many tons for a few $100s per ton. Starship is designed to lift roughly 100 to 150 tons to orbit per flight, and even optimistic long-term cost targets sit far above sea freight per ton. Bulk imports like grain, cement, steel, and fuel are exactly the low-value, high-weight goods that ocean shipping handles best and rockets handle worst. To move Uganda's annual bulk imports by rocket, you would need tens of thousands of launches per year over the same populated corridor. The capital cost of a tropical spaceport runs into billions, and the per-ton cost would likely be tens or hundreds of times higher than a ship plus a train. For bulk cargo, the math simply does not close. Let us visualize the trade-off honestly. This animation compares 3 ways to move a ton of cargo from the Indian Ocean to Kampala. Option 1 is the existing sea plus rail plus road corridor, which is slow, taking days to weeks, but extremely cheap and mature. Option 2 is an upgraded standard gauge railway, which is still the most realistic real-world improvement, cutting costs and time while staying on the ground. Option 3 is the rocket, which is astonishingly fast, under an hour, but priced for satellites and emergencies, not for cement. The pattern that emerges is clear. Rockets win dramatically on transit time and lose dramatically on cost per ton for bulk goods. So the rocket concept is not the answer for everyday bulk imports, but it might have a narrow niche for extreme high-value, time-critical cargo, which we will return to at the end. Geography raises serious environmental questions too. Kampala sits within the Lake Victoria watershed, a principal source of the White Nile and a shared water body supporting tens of millions of people across 3 countries. This watershed view shows how streams and wetlands drain toward the lake. A rocket landing facility needs large volumes of deluge water and can produce contaminated runoff, exhaust residues, and heat. Placing that anywhere in this catchment risks polluting a lake that is already stressed by nutrients, fishing pressure, and invasive species. The papyrus wetlands that fringe the lake are natural filters and critical habitat, and they are exactly the flat, low-lying land a spaceport planner might be tempted to use. From a hydrology standpoint, this is a high-risk siting problem. Protecting the watershed would push any facility onto higher, drier ground, which then reintroduces the slope and access problems we already saw. Geology adds another layer of caution. The flight corridor crosses the East African Rift, one of the continent's major seismically and volcanically active zones. This geology overlay highlights fault lines and volcanic formations through the Kenyan highlands near our second waypoint. A launch or landing platform demands an extremely stable foundation, and building heavy pads, fuel storage, and tall integration towers near active faults introduces earthquake risk to a facility already handling explosive propellants. The coastal launch point avoids the main rift, sitting on the platform in international waters, but the inland landing site cannot escape the plateau's fractured geology entirely. Any real proposal would need detailed geotechnical surveys, borehole sampling, and seismic hazard modeling before a single foundation is poured. This is precisely the kind of survey-grade work that a conceptual map like ours can flag but never replace. Let us talk about the people beneath the trajectory. This risk zone map sketches the safety buffers around a hypothetical landing site near Kampala. Rocket operations generate extreme noise, sonic booms, intense heat, and a small but real probability of catastrophic failure. Standard practice requires large exclusion zones, sometimes many kilometers across, kept clear of population during launch and landing operations. Around a dense, fast-growing capital city, clearing and maintaining such a zone could displace communities and permanently restrict land use. The overflight corridor crosses inhabited coastal Kenya and the highlands, meaning abort scenarios and debris risk could fall on other nations' citizens, reintroducing the very cross-border dependency this idea tried to escape. Community benefit must be weighed honestly against community risk. A project that promises cheaper goods but imposes noise, danger, and displacement on the poorest neighborhoods would fail basic tests of fairness and consent. This OpenStreetMap context view around Kampala shows the practical siting challenge. You can see the road network, built-up areas, wetlands, and the lakeshore all competing for space. A spaceport needs land ownership secured, protected areas avoided, and reliable access for heavy transport of the rockets themselves, which are enormous. Ironically, moving a Starship from a coastal manufacturing point to an inland site would still require the same congested corridor we were trying to bypass, unless the vehicle flies itself and empty. Power supply, propellant production or import, skilled workforce, and emergency services all need to be within reach. When you overlay all these human constraints, the map tells a consistent story. The inland end of this concept collides with a living, occupied, ecologically sensitive landscape, and every solution to one constraint tends to worsen another. Let us turn this concept into something you can actually open and inspect. Everything we have discussed ships in a downloadable bundle, and the first file is a Google Earth KML capturing our real waypoints. Here is the core of that file. It places the deep sea platform, the 2 corridor waypoints, and Kampala then draws a line connecting them. You can load this directly in Google Earth, tilt the view, and fly the corridor yourself. Treat these as conceptual planning points, not surveyed coordinates. They are accurate enough to reason about geography and distance, but any real project would refine them with field teams, aviation authorities, and environmental assessments before they meant anything on the ground. The bundle also includes a GeoJSON version of the same route for web mapping and analysis, plus a MapLibre viewer that renders it over free OpenStreetMap-based tiles. Here is the heart of the GeoJSON. Because it is a plain open standard, you can drop this into QGIS, a Jupyter notebook, or any modern web map. The companion MapLibre HTML file loads this file, fits the map to the corridor, and lets learners pan from the ocean platform to Kampala. This is how you move from a narrated concept to a shareable, inspectable artifact that colleagues and community stakeholders can open without any paid software. Remember, an open file invites scrutiny, and scrutiny is exactly what an idea this bold deserves. For those who like Python, the bundle ships a Cartopy script that plots the corridor over a coastline and marks each waypoint, giving you a quick reproducible figure for reports and slides. Here is the essence of it. It draws the map extent from the Indian Ocean to Uganda, plots the 4 points, and connects them. You can extend this to sample a digital elevation model along the route, generate the elevation profile we looked at earlier, or add the Lake Victoria watershed boundary. The control point CSV, a README, and a manifest round out the package so anyone can reproduce, critique, and improve this analysis. This is the difference between a viral headline and a real planning conversation. So, would SpaceX spaceships answer Uganda's reliance on coastal states for sea access? Our honest verdict is no, not for bulk imports. The economics fail badly against ships and railways. The terrain and watershed around Kampala complicate a safe landing site. The rift geology adds seismic risk, and the overflight corridor still crosses neighboring nations, so the dependency never fully disappears. The realistic answer to Uganda's landlocked challenge remains investment in standard gauge rail, better ports, and regional cooperation. Yet the sea-based launch idea is not worthless. A floating platform in international waters is a genuinely clever way to bypass territorial politics and there may be a narrow future niche for ultra-fast delivery of tiny, extremely high-value cargo, medical or emergency payloads rather than cement. If you want to take this further, refine the waypoints with real survey data, model the exclusion zones formally, consult affected communities across 3 countries, and always separate an imaginative concept from an engineering approval. Thank you for exploring this terrain with me. Please see the references for further reading.